this video, I'm going to cover the solution for this specific coding question and explain this piece of code. And at the same time, I'm going to go over the general steps we should follow in a real coding interview. So let's get started. So in a real coding interview, the first step is always try to understand the question. If there is anything unclear, please bring up the question to the interviewer, and at the same time think about some edge cases. So let's read through this question. So you're given a grid of size n by n, and each cell of this grid has a lamp that is initially turned off. And you are also given an array of the lamp position lamps, where lamp I is equal to row I column I, indicates that the lamp at grid row I column I is turned on. So when the lamp is turned on, it also illuminates its cell and other cells in the same row, column, or diagonal. So finally, you're given a query array queries, where query I is row I, column I, and for the ith query, determine whether the corresponding grid is illuminated or not. And after answering the ith query, turn off the lamp at grid row I, column I, and its 8 adjacent lamps. And a lamp is adjacent if its cell shares either a set or a corner with the grid row I and column I. So return an array of the integer answer. Well, answer I should be 1 if the lamp is in the ith query was illuminated, or 0 if the lamp was not. So let's take a look at this question. For this example, we have a 5x5 grid, and we turn on 0, 0, the lamp at 0, 0, and then the lamp at 4, 4, which is this corner. And after that, those are the lamps that are illuminated with those lights, the two lights on the upper left corner and bottom right corner turned down. And suppose we have query 1, 1, so we are going to set this one as 1 because it is illuminated. And after that, we need to turn off all the 8 neighbors and the lamp itself. So we see that we turn off this one, and because this one is turned off, all of the lights on this row, and this column should be turned off as well. But since we have the bottom right corner lamp turned down, so it is not going to turn off this one and this one. And then we try to query this position. The light at this position is not illuminated, and we try to turn off them. And because none of them are on, it's just so those two lamps are just illuminated by the bottom right corner light. So we are not going to do anything for that essentially. So this is a very good example. So let's see some constraints. So the constraint says that the grid is not going to be empty, and also the length of the lamp is anywhere between 0 to 20k, which is a pretty large number. And also it says that so the grid can be very large and the lamps can be pretty long, and also each of the lamps is like a 2D length of 2 of the array. And also for the queries, a similar situation. I'll just not read through this. So the next step after we understand the problem is to think about solution and discuss the solution with the interviewer, and talk about the runtime, space analysis, etc. And then after that, if we get a good agreement, good talk, then it's time for us to start doing some coding work. So let me go through the solution and also at the same time go through this piece of code to explain what the solution is. So because we have the matrix, the grid can be very large and it can be anywhere between 1 to a billion. So it wouldn't be a very good solution if we try to simulate the whole process, like we try to turn all of them on and then turn all of them off. It is going to be very time consuming. So instead, based on the rule, the light is turned on, we will define 4 of the maps, like the row, column, diagonal, and diagonal 1, diagonal 2. So diagonal 1 means the backward slash, something like backward slash, and diagonal 2 means forward slash. So you can see this is defined as a map because anywhere along the same row there can be multiple lights turned down, and similar for the column as well, and also the diagonal free 1, diagonal frequency 2. So we define those 4 maps. Each of the map indicates how many of the lights are there on the corresponding row, on the corresponding column, or the diagonal, the forward diagonal or backward diagonal, for example. And then we have the set defined, which is called lights on. This is to record the positions we have lights turned down. So we are going to go through all the lamps, and we initialize the pair with the corresponding position of the lamp on, and we put it into the lights on set. And then we are going to update the row frequency map, column frequency map, diagonal 1 frequency map, and diagonal 2 frequency map. And we notice this one, there is a if branch here because for the input, maybe the same lamp can be turned on multiple times. So if it is turned on multiple times, we don't need to do that multiple times. We just need to do it once. Otherwise, it is going to cause some issue when we update the frequency maps for each of the frequency maps. And after we go through the lamps array, we have turned on all the lights we should turn down and updated the frequency map for the row, column, and the 2 diagonals. And the next step is to calculate the return result and also turn off the lights. So in the next step, we define a array, which is the semblance of the query, and that is the result we are going to return. And we are going to iterate through every of the element within the query's array. So we define 2 helper functions. One is illuminated. This is to try to judge whether the corresponding position, the light on the corresponding position, is illuminated or not. And then the other helper function is to turn off the lights on the position itself and all the 8 neighbors. So let's read through the helper functions. So the first one is illuminated. So illuminated, it is just we pass several of the parameters. The first one is the position of the light, and the second one is row frequency, column frequency, so on and so forth. So if the row frequency for the corresponding row has a value larger than 0, then it means there is at least one light on this row that has a light on. So if there is at least one light on the same row that has a light on, then it means the light is illuminated. Then we are going to return 1. So similar for other conditions. If none of them has a frequency larger than 0, then it means the light is not illuminated. And then let's see the helper function turn off the neighbor. So for the turn off neighbor, we are going to go through all the positions, all the 8 neighbors, and the position itself, which is within this for loop, the 2 round of the 2 layer of the for loop. So if the lights on is, if this position is not contained in the lights on, then it means there is no the corresponding position hasn't been turned on before, or it is already, or the corresponding position has already been turned off. So if that's true, we just continue. Otherwise, we will need to remove the position from the lights on, remove the light from the set, and then we will need to update the corresponding frequency for each row, column, diagonal. So that's pretty much it for the general solution, how to solve this problem. So the runtime for LAMP, the runtime for the overall runtime is going to be n plus m. So n is I think it might be pretty yeah, it might be confusing to mix this n. So let's say it is x and y. So X means the length of the lamps, and Y means the length of the queries. So the overall runtime is going to be O X plus Y. So that's it for the solution of the question. So after you're done with coding, don't forget to do some testing. So if it's runnable platform, please run it, set up some test cases. Otherwise, you need to go through it manually. So that's it for this coding question and the overall procedure, how to behave in a real interview. If you have any question about this solution or about the whatever, so feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.